handle this. Hi, QiDi has sent me a QiDi Q2 3D printer for review. It's very well packed. I don't see anything damaged. And the hinges has some resistance. And they're all flush. Yeah, good assembly. It looks like a real filter. Okay. It has two magnetics here. It could have crashed with the glass panel. PTFE tube is crashing with the glass panel. I think it's too long to cut it. This is silicone rubber. So yeah, if it's here, it's going to rub against the glass anyway. Yeah, I think it's too tight. Okay, I'm going to replace this with a Capricorn tip. It's going to lightly place with the glass. This is it. Okay, so I think I'm going to use this single PTFE tube. The original tube that comes with the printer, it has a coupling, and I think it gives a resistance to the filament to go in there. The Capricorn tube is much thicker than the stock tube. I think it's easily kink if I bend it and can cause trouble with the TPU. Yeah, just about a good length. I think they have a sticker over the camera, and this could be the LED lighting. And the filament holder is very flimsy. Could be better, but it should get the job done. Yeah, it's smoother with when I remove the coupling here. You need to remove this one too. It looks like a 3D printing spacer. Yeah, you better need an electric screwdriver because it's very long thread. 2 more to go. Look at the size of the screw. It's super long. I think they put too much grease in here. Going to fall onto the print bed. Okay, this is the build plate. It has 2 sides, same texture on both sides. And they have a nozzle wiper here, which is in the center of the build plate, so you can flip it over and it is still in the center. Yeah, there's a catcher in the back here. Yeah, very easy to install. Adjustable. If you put it in a certain angle, it will crash with the door. Okay, let's try to power it on. Okay, let's try English. Remove the box. Okay, I already did that. Okay, it's doing some calibration, I think. Self-checking. Okay, it's doing auto leveling. It's very loud. Okay, let's connect this to the Wi-Fi system. Update detection, online update, new version, discover. And they put a lot of grease here. So I'm going to spread it on the linear rail. Quite a lot of grease here. And for the door hinge, it works fine, but something to note that if you open it too wide, it's going to clash with the plastic frame and the front. If you force open it more than this, it's going to break a front panel plastic. So this will be the widest that it can be open. And if I compare it with the K2 Plus, it can open wider than the QiDi Q2. And I noticed that the diameter of the lead screw is larger. I mean, probably the largest lead screw that used in the 3D printer. And they are driven by its own separate motor. The nozzles will probe on the left and the right of the print bed closer to the lead screw. This is how it level left and the right side of the print bed. This would be the heater that would be necessary for printing the high temperature filament. That it has two separate Z-axis motor and it's not synchronized by the belt, and deep down in here is 350 watts. I think it's mean well power supply, and you can switch the voltage. There's a small switch in there. Okay, when it should be pushing against this. This should be a filament sensor. So when you push the filament into the PTFE tube, it will stop here and the sensor will catch it. The extruder will pull the filament down when you do a loading function. And they place the cutter here. Okay, let's load the filament. Filament load. Okay, so it demonstrates how you should do. So it's going to heat up. Okay, now you can see that is feeding the filament. You should see the filament come out from the nozzle. Okay, this is QiDi Studio. Add primitive cube. This is the same as the Orca slicer. Next, I'm going to scale this to 50 by 50, and I will just pin in one layer, 0.2, and the filament will be the PLA. QiDi has made a presetting value for the filament, so I like when the manufacturer do the test on each filament and preset the value for the nozzle's temperature, bed temperature, flow rate, and also a chamber temperature, so that the user will not have to try and error finding those values and spend like half of the row of the filament just to get the setting right. I'm going to clone for 4 more. This is how I do the first layer test. I'm going to slice it. So first I'm going to test this with the PLA, and then I'm going to test it again with the ABS. Let me check the device. You need to enter the IP address of the printer in the printer, and it's now connect to the Wi-Fi network. I'm going to do auto bed leveling. Every time I start the print, click on send. It's leveling the bed, and I suggest that you should do this every time you start printing. It's not worth the time if the print fall off the bed. You spend like a few minutes more on the bed probing. Okay, during the bed leveling, the nozzle is 140 degrees Celsius, and the bed is 60 for the PLA. Okay, here's the first corner. Yeah, I think it's perfect. First layer. Perfect. So with the PLA, it works really well with the bed leveling. And next I'm going to test this with the ABS, because with the ABS, the build plate temperature is going to be like 90 degrees. Can cause the warping on the build plate. So I'm going to unload the filament. When unloading, it will warm the nozzles and then it will heat up the nozzles to 240 degrees. Yeah, this one is cutting. They have a like a extension here that will clash with the cutter lever on the sides. Remove the filament like this and put in a new row of the filament. Okay, now change the filament type to ABS. Gonna slice it and print the plate. Click on send. Okay, now it's probing at 90 degrees Celsius, print bed. I noticed that a chamber ventilation fan is running. Chamber temperature is still constant at 33 degrees Celsius. It should turn off the chamber fans because this is ABS. Let's see if it turns off when it start printing. Can I start printing? The chamber ventilation fan stopped working, but the heater is not working with the ABS. So the target temperature is 0 degrees Celsius. But if you want to heat the chamber, you need to manually place the required temperature. So now I put it to 45 degrees Celsius. The heater is kicking in. Okay, if you look at the PTFE tube, it's a lot of bending on the PTFE tube. If I use a stock tube, it's going to kink, but the Capricorn tube is thicker, much better than the stock one. With the ABS, 2 out of 5 is too close to the nozzles, which is the one on the right side. Okay, you can see that this 2 on the right side is too close to the nozzles. The center one is perfect, and the 2 here is also a bit too close to the nozzle, but not as much as this 2. So you need to preheat the build plate 90 degrees for, I recommend 10 to 15 minutes before start probing for the bed leveling with the ABS. This is the same for my QiDi Q2 Plus, that I also need to preheat the build plate to get the best first layer for the high temperature filament. When the nozzle is too close, it will be difficult to remove. So if you can't remove it from the build plate, you need to spray it with the isopropyl alcohol. And it will be easy to remove. Spray with the alcohol. The isopropyl alcohol with the water, 50-50, and I can use it for cleaning and also removing the stubborn filament that stick on your build plate. See, no scratch mark at all. Okay, this is what I am going to test print with, the side mirror cover of Lexus IS250 that I reversed in my previous video. Let's see if it can print this part. Thin shell, 2.8 millimeters in the thickness, and it's quite tall. It's 27 centimeters, but the QiDi Q2 has the maximum volume for the height. I think it's 256, but if I print it like this, it could be less than 278, so I'm going to use its maximum height for printing this. This will test the heating of the chamber and the build plate adhesion, also the precision of the nozzles. I will preheat the bed to 90 degrees, wait for at least 10 minutes, and I also preheat the chamber to 45 degrees. And I'm going to drop the step files that I made. Okay, I make the orientation. I will lay on this face. And then I'm going to activate the support using a 3 support. And for the brim, I'm going to choose the outer brim only for 5mm. And for the infill, I'm going to use the stock value because I want to check the quality of the print, how well the heater chamber works with the ABS. Because if you don't use the heater chamber printing the ABS in a thin shell and tall like this, it's going to warp and sometimes just pull out from the build plate. Okay, let me slice the plate. Okay, it says right here 7 hours 35 minutes. It takes about 6 minutes to heat up to 90 degrees. Okay, now the graph is flat. It's reaching 90 degrees. So from this point, I will wait 5 minutes. It can have some heat soaking on the build plate. So after preheating, the first layer on ABS filament looks very good. So you need to preheat the build plate, otherwise it'll be too close to the nozzles. Now I increase the chamber temperature to 50 because the part is quite tall and thin. QiDi Q2 allowed the PTFE tube from the left side of the machine, not in the center. So when the nozzles move to this corner here, the PTFE tube has to be longer than the other machine that route PTFE tube into the center of the machine. The temperature sensor, it says the chamber is now 53 degrees Celsius. When I use the thermal camera to capture in the front glass, it says 50. Now I'm going to move to the side. It's a side glass window. Say 46 here. And if I now why it's so hot here, this area, closer to the LCD monitor. On the top of the glass is 48. So I guess that the temperature, I think is close. The build plate adhesion is very good for the ABS. There's no lifting in any point, and the removal is also very easy. So you don't need to use the adhesive for printing with the ABS. Okay, let's take a look at the print quality. I have printed the Miller cover with a K1 Max, K2 Plus, and this one is QiDi Q2. And I can say that with the ABS filament, this is the best printing quality that I get from the 3D printer. The artifacts on the outer shell is very low. This is normal for the top layer. And the printer prints successfully. Normally if you print the part with the ABS this size, this thin, without the heater chamber, it's going to warp and pull out from the print bed. The heater chamber works very well. So in the next video I'm going to test the QiDi Q2 with other high temperature filament like polycarbonate and PETCF and probably the nylon. But this day, if you are printing the automotive part for the strength and the temperature resistance, my go-to choice would be polycarbonate, PETCF, ABS. That would be the three filament that I often use. Okay, let's compare it. On the left is the print from QiDi Q2 Plus, and this one QiDi Q2. You can see that with the Q2 Plus, it has a more vertical line artifacts from the printer more than the QiDi Q2. See, and the layer line, I mean, you can see more clear for the layer line. This one is smoother. So if you can have a better print surface quality, this one is rougher, this one is smoother. You can feel it. So when you sand it and apply the primer painting, this one will be faster to paint than the one from the Q2 Plus. These two print from the same ABS filament, actually from the same row. From the top, the QiDi Q2 does better. Printing with the overhang, because I noticed that when it prints the overhang, it prints with the lower speed. I forgot to mention that these two are print with the standard profiles from the slicer. This 2025 manufacturer, they should do the test with a different filament and put the profiles in their software so that the user like you and me don't have to try out with multiple rows of the filament to get the best result. See here, it's quite obvious that the print from the Q2 Plus is the surface quality is rougher than the QiDi Q2. Okay, what's the difference then? The Q2 Plus, I paid like $1,900 here in Thailand. And this one is only $499, probably $600 including the multi-filament. When I print with the Q2 Plus, the time spent on the printing is 5 hours and 45 minutes. And this one is over 8 hours. 8 hours, 5 hours, 45 minutes. So it's quite different for the time, but the machine price is like 3 times more than the QiDi Q2. Yeah, it's larger of course, but yeah, but for the price, I would say I didn't expect the machine in this price range can print the quality part like this. I didn't even expect that it will finish the print, but it does without any issue. Okay, here's my first review with the QiDi Q2. I will release more video testing with other type of the filament. Thanks you guys for watching. See you in the next video.